Hi everyone. So let's pretend I am calculating the Simpson's Biodiversity Index for this coral reef ecosystem. Here's my data. I've got one sea turtle that I saw, 3 jellyfish, 2 clownfish, 1 tang, which is another type of fish, 2 coral, 2 sea stars, 1 eel, and a seagrass species. So generally you want a lot more data than this, but this is just an example. So I've got my data ready to go to calculate my Simpson's Biodiversity Index. And we've got our equation. So here's the equation. To calculate our biodiversity, we're going to have 1 minus sum of little n, then in parentheses n minus 1. Sum of is sometimes written with this kind of silly symbol. So sometimes you see that as well. And then over that, you've got the denominator of capitalize N, big N minus 1. So what do these n's mean? This big N, write it down here, big N equals total individuals in the ecosystem. Whereas little n over here equals number of each species. So I think it'll make sense once we calculate this out. So first, the easiest place to start is to start down here. Let's start with our denominator. Capitalize N, n minus 1. So here we go. We've got our data down here. We've got each of the individuals per species, and let's calculate our big N. Our big N in this case, let's add these guys up. So we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Our big N is 13. Now let's do big N, n minus 1. So now we've got big N, n minus 1. This case we're going to have 13, 13 minus 1. We've got 13 times 12. I'm going to go ahead and put that in my calculator. And I've got 156. So right now we've got 156 for our denominator. Now let's go ahead and calculate the sum of n times n minus 1, this little n. To do this, we've got our species numbers here. So to do this, for each one of these, we need to go n times n minus 1. So let's start with our sea turtle. So sea turtle, we've got 1. So this will be 1 times 1 minus 1. In this case, that is 1 times 0, which equals 0. Now let's do that for our jelly. We've got 3 times 3 minus 1, 3 times 2, which equals 6. Our clownfish, 2 times 2 minus 1, that's 2 times 1, 2. Our tang, 1 times 0, 0. Our coral, 2 minus 1, 2 times 1, which is 2. Our sea star, 2 minus 1, 2 times 1, 2. And last we've got our eel, or we have seagrass too. So 1 minus 1, that is 1 times 0, 0. And then our seagrass, last but not least, 1 minus 1, which is 1 times 0, and 0. So now we've got all of our n's times n minus 1. We've got this part, but now we need to take the sum of that. So to take the sum, we then add up all of these n times n minus 1s. So let's see what we've got. We've got 6, 7, 8, 9, 10, 11, 12. So this part right here, sum of n times n minus 1, this now we've got 12. So we've got our numerator, we've got our denominator. Now we just need to subtract that from 1. So let's go ahead and see what we've got. Now we've got our diversity equals 1 We calculated our sum of n over n minus 1, which is 12. And then before we had 56, 156. Okay. So let's first do what's inside of the parentheses. I'm going to go ahead and put that in my calculator. So now we've got D equals 1 minus 0.077. Then our diversity then equals 0.92. So for this ecosystem and this data set that I collected for this coral reef ecosystem, we found out that it has a biodiversity Simpson's index of 0.92. And remember, we're talking about a scale from 0 to 1, with 1 being the highest biodiversity and 0 being the lowest. So in this case, this example of an ecosystem, it has pretty high biodiversity.